is Abhijit and you're watching AB Study Circle. If you haven't subscribed my channel till yet, please press the subscribe button and don't forget to hit the bell icon so that you don't miss any video from AB Study Circle. Let's dive in. In this video, we will be discussing about law of degradation of energy. See, first law tells us energy is conserved. That means it quantifies energy. Whereas second law says that energy at higher temperature is more significant than same energy at lower temperature. That means it basically says about quality of energy. It talks about quality of energy, right? Okay, so let's get more deeper into the second law of thermodynamics, or statement of the second law of thermodynamics, that energy at higher temperature is more significant than same energy at lower temperature, and we will discuss this statement with the help of your concept of available energy, which we have discussed in the previous video. Let's move further without wasting any time. Okay, so see, we have this available energy that is operating between your source temperature T1 and the surrounding, and this engine is producing maximum work, right, from receiving Q1 amount of heat from this source and rejecting Q2 heat to the surrounding. And we have that equation with us, that is maximum work is equal to Q1 1 minus T0 by T1 from the available energy for a cycle concept, right? So let's have two cases. Case 1, where we have a heat engine that is operating at 500 Kelvin, okay, giving Q1 amount of heat, that is 20 kilojoule. This heat engine produces the maximum work output by releasing Q2 heat to the surrounding, which is at 300 Kelvin. In the next example, we have T1 that is maintained at 800 Kelvin. Again, it is supplying Q1 amount of heat, that is 20 kilojoule, to the heat engine, which is producing some maximum work. It is again rejecting Q2 heat to the surrounding, that is maintained at 300 Kelvin. Now what we are doing is that we will see that how much work, maximum work, can be obtained when the same heat supplied is being transferred from two different source temperatures, and then we will see how the heat is significant for which temperature, right? Okay, so let's have the maximum work output for this one, case 1. So Q1 is what? 20. 1 minus T0 is 300, and we have it's T1 as 500. Okay, so we have 20 multiplied by that, it will be 2 by 5, that is 20. Oh sorry, it will be 8. It will be 8. Okay, so we have this 8 kilojoule, right? 8 kilojoule. Here the W max, let's calculate for this. Again Q1 is 20, that is the heat input, and 1 minus T0, that is the surrounding temperature, that is 300, and the source temperature is 800 here. Okay, 20 multiplied by, it is 5 by 8, that is, it will be 2, it will be 5, it will be 5, that is 25 by 2, that is 12.5 kilojoule. Right. Now see, this, when the heat supplied 20 kilojoule was at temperature 500, the maximum work output was 8 kilojoule. But when the heat supplied 20 kilojoule is at 800 Kelvin, then the maximum work output was 12.5 kilojoule, which means when the energy is at higher temperature, the work output was maximum. That means Q1, that is 20 kilojoule, was much more significant when it is at 800 Kelvin rather than when it was at 500 Kelvin, because the W max was 12.5 kilojoule when it was at 800 Kelvin, and at 500 Kelvin it was 8 kilojoule, which means the statement which we have earlier made, that the energy at higher temperature is much more significant than energy at lower temperature, is evident from these two examples. That means it can much more further, let's further deduce or describe these with the statement, is that the energy which is at higher temperature will produce more work, and the same energy which will be at lower temperature will produce less work. That means the energy is degraded when the temperature decreases, right? So the second law of thermodynamics is also known as law of degradation of energy. Hope you understand the law of degradation of energy with this small example.